Hello, Seung-Tak. Delighted to welcome you back to teach another course for us. Before we talk about your course, can you please introduce yourself and your research interests?
Yeah, hello everyone. I'm Seung-Tak Ryu from KAIST, Korea. I got my PhD degree from KAIST in 2004, and then I joined the Samsung Electronics and worked there for a while in the analog and mixed signal IP design team. And then I joined academia. And my research interests include analog and mixed signal IC design with emphasis on data converters. I served on multiple TPCs of IC-related conferences, including ISSCC, ASCC, CICC, and eCirc. And currently, I am serving as an associate editor of OJSSCS and OJCAS, and also I currently working as a guest editor of JSSC. And I also served as a DL of SSCS.
Can you please discuss the motivation behind the course and its relevance to our industry?
Okay, well, I think key distinction from human being and machines lie in intuition. So and also I think intuition can be built on based strong fundamentals. So for analog circuit design, I believe intuition is more important than extensive simulations that enables to find for you to find potential problems in your circuit, which the simulation tools cannot show you. So in this course, I aim to foster intuitive understanding on analog circuits rather than mathematical analysis. So I want to help participants build a solid foundation for analog circuit design. And for that, I think op-amp is the best topic. Op-amp is the most representative analog building block with wide range of applications. All analog design issues are embedded in there, like gain, bandwidth, feedback, stability, frequency response, transient response, noise, and matching. So again, through our study on op-amp, I want to help participants build a solid foundation for analog circuit design.
What are some of the main highlights the participants can expect from your course?
Well, I plan to cover as many practical design issues as possible. For example, in fully differential op-amps, the common mode feedback circuit is indispensable and its stability is very important, should be guaranteed. But often those aspects are overlooked. Similarly, input and output common mode ranges and the bias for them are crucial, but these are not sufficiently emphasized, I think, in most design discussions. And furthermore, understanding feedback and stability is essential, but some engineers struggle with these concepts. So through this course, I want to again help participants gain an intuitive perspective how to understand circuits, focusing on real-world design issues.
Seung-Tak, would it be true
Mhm.
to say switch capacitor amplifiers are a key building block for ADCs these days?
Yes, absolutely. For instance, in pipeline ADCs,
Mhm.
the residue amplifier is one of the most critical building block, and its performance heavily relies on the performance of operation amplifiers. So in the past, a good op-amp designer was actually a good ADC designer. So you can recall that many excellent ADC papers introduced innovative op-amp design ideas. Although these days, low power dynamic amplifiers like FIA and ring amplifiers are very popular, but I still believe that strong fundamental in operation amplifier design are essential even for these such architectures. In this course, we discuss design considerations for achieving both accuracy and speed in switch capacitor implementation, including loop gain, bandwidth, slew rate, and settling. Also, recent hot topics, as I just mentioned, such as ring amplifiers and FIAs will be also introduced.
The design projects you mentioned sound very interesting. Can you please expand on them?
Well, in both projects, participants will proceed step by step to achieve the given design targets. The first project will be a design of fully differential op-amp. We will consider key aspects from start to finish. That includes choosing the right architecture for given input and output common mode range, and bias circuits for given signal swing range, and also determining cascode or cascade for target gain will be discussed, and implementing frequency compensation for stability
Mhm.
and the common mode feedback circuit for fully differential operation will be included. And for the second project, we will design a switch capacitor gain amplifier targeting the implementation of sample and hold amplifier and MDEC for pipeline ADC. So we will cover determining loop gain, bandwidth, and slew rate for settling accuracy. And we will implement switch capacitor common mode feedback circuit and
Mm.
also building test benches for verifying the stability and performance will be studied.
In your opinion, what's the target audience for this training course?
Well, this course has been designed for those who already have some analog IC design knowledge, but somewhat lack extensive design experience, or for engineers who wish to strengthen their fundamental understanding for data converters. So it will be particularly valuable for those who want to design through intuition
Mhm.
rather than by relying on simulations.
Thank you so much for your time, Seung-Tak. We look forward to your course in January.
Well, yeah, thank you for offering me another opportunity of a lecture. And I will be looking forward to meeting engineers and the research staff from all around the world in January. Thank
Great.
you.
Thank you.